All right. So good afternoon, good evening, everyone. Um, I will try and make this as brief as possible because I know we're a bit tired. Can you can't hear me? Can you hear me now? Okay, great. Yeah. So I'm going to present on robotics and the African dream, and I'm going to do that in the lens of the Design and Technology Institute. So my name is Melinao Volto, Meli for short. I'm a mechanical engineer and mechatronics engineer, and I have a mechanical engineering degree from Ashesi University, and I have been specializing in mechatronics, robotics, and machine design. So I'm currently heading the robotics and computer aided design and computer aided manufacturing division at the Design and Technology Institute. And so today I'm going to talk about robotics in the context of the African dream and essentially DTI's approach to robotics and perhaps to try and curb some misconceptions that you may or may not have about robotics. Is that okay? Great. Okay. So I'd like to start with what is robotics in the first place. A lot of the time, people think about robotics and they think about some of the um, adaptations of robotics in movies or series or any sort of mainstream media that we are used to, right? So the first thing that comes to mind is usually humanoid machines. So they look human, but then they act mechanical in some sort of way. They talk in a very strange format. They do um, uh, very weird. They have very weird behaviors, right? But in the real world, robots are essentially just machines that we use to perform tasks, right? So the term robot or the term robotics can span across so many different, um, in this case, principles or so many different disciplines, if I'd call it that. And yeah, ideally, we use robots to make tasks easier for us. So, say I want to be able to move an object from this side of the room to that side of the room, and I don't want to do that using my human effort. I would employ a machine to do that, and that machine would be a robot. So, on a very basic, rudimentary level, that's what we'll call a robot, or that's what we'll term as dealing with robotics, basically. And when we use robots to complete tasks, we want to be able to complete tasks that are probably too difficult for human beings. Say you want to carry an object that's too heavy, or you want to complete a task that may be too boring for a human being. You'd probably use a machine to do that instead. So that is essentially what robots are meant to do for us. Another thing we can talk about when we look at robotics or robots is how they can possibly do tasks that are probably too difficult, sorry, too dangerous for human beings to engage in. So perhaps you want to be able to collect lava samples from a volcano, right? That would probably be too dangerous for a human being to accomplish. So you would probably use a robot to do that. So essentially, that's the kind of things we want to look at when we look at robotics in the real world. And moving on to robotics in the real world, there are five main areas that you want to look at. If you are someone who may be interested in looking or going into robotics further down your career, there are five main areas that you may or may not be looking at specializing in. One thing you find really interesting in the industry is that you won't have a lot of people who are working on so many things regarding a robot at a time. I know in movies and series, you have like this one scientist or engineer or technician who is building the robots, they are programming them, they are testing them, all of those things all at the same time. In most cases, in the real world, that won't happen. Um, different aspects of the robot would be allocated to different types of people with different types of skill sets. And that is really important to note. So, the first thing is human robot interface. So, one thing about robots is that even though we are able to have them perform tasks that would probably be repetitive, there are cases where you need to be able to communicate with a robot and you need to create an interface or a platform to be able to do that. And that's what a human robot interface is for. One very simple example of a human robot interface or an HRI is a gaming controller. So, like on a PS5, right? You take the gaming controller and then you press buttons, you push joysticks, and then it's reacting or it's yeah, essentially it's reacting to the actions that you are making. That is an example of a human robot interface. The second is mobility. If a robot has to perform a task in any environment, then it needs to be able to move within that environment. With the first example I gave, moving things from one end of the room to the other, you need the robot to be able to move, right? So, in developing and designing those systems to enable the robot to move within its environment, you need to be able to understand the aspects of mobility. In this case, kinematics, robots kinematics. And you could develop so many different systems to achieve that. There's obviously more than one way of solving that problem. So you could think of using wheels, like with a robot rover, or you could think of using propellers, like in a drone. You could think of some other propulsion system of sorts, but ideally, you need to be able to make sure that the robots can move within its environment. The third is end effectors. To be able to complete that task, the robot has to have a section of its body, if I should say, that is actually performing that task. So let's say you want, I'll just go back to the first example. You wanted to pick up that object. In this case, what part of the robot is going to pick up that object for you? Are you going to use a system that allows the robots, the end of the robots to, let's say, stick onto the object, or is it going to grip the object, or is it going to hook itself to the object? Ideally, as a designer or as a robotic engineer, you need to be able to develop that system or determine what kind of system is best to fit that task you are trying to complete. Then we want to look at programming. So in this case, programming is the instructions that you would give to the robot in a language that it would understand. Previously, in the other presentations, we looked at software development and we looked at different programming languages and programming frameworks. So essentially, the same thing applies to robots, because all you are doing is telling a computer to perform a set of instructions through a language that it can only understand. And you would have to do that by writing programs or by programming. Then the fifth one is sensors. To be able to interact with its environment, a robot needs to be able to perceive the things around it. So to be able to touch, let's say, you'd have some sort of pressure system where, based on how much pressure is being applied, the robot knows that it has hit an object, or some proximity sensor, or light, sound, temperature, things like that. Those systems or those devices allow the robots to gain data or feed itself with information to be able to properly interact with its environment. So let's say we are picking up those objects again, sending them across the room, and we get to this obstacle over here. How can we tell that it's an obstacle? And once we tell that it's an obstacle, how do we move away from that obstacle or maneuver from it and then move somewhere else? Ideally, this would be the job of a sensor. So you are basically taking all these five main areas and then putting them together to make your one simple robotic system. So you could think of many different types of robotic systems that exist in industry, and they all should have either all five of these capabilities, or perhaps majority of them, essentially. If there's anything you don't understand while I'm presenting, you can just stop me and then ask. If that's okay. Okay. All right. So now I want to talk about robotics and the African dream. So far we've looked at what the African dream is like, what it means to be able to build certain infrastructure so that Africans can, basically provide for themselves. Africans wouldn't need help to be able to perform certain operations on their own, right? And in this case, if we are using tech and innovation and we're using robots to achieve those dreams, there are certain things that you want to look out for. So if you are someone who is venturing into robotics and you are interested in fulfilling or accomplishing the African dream, these are some of the things you need to look at. First is a deep focus on manufacturing robotics. One very pressing issue that we currently face in Africa is the lack of manufacturing systems. A lot of the things that we use here in Africa are imported. And when they are imported, before they are imported, they are obviously manufactured. One very simple example is this microphone, right? There are seemingly no available infrastructure or organizations in place on the African continent that do any sort of large scale manufacturing of microphones or smartphones or TVs or laptops or anything like that. In this case, if you want to be able to realize that African dream, then you need to start focusing on manufacturing. In that case, you need to be able to build robots that are fulfilling some manufacturing process. So let's say cars that are going down an assembly line. I'll give you the example of the Volkswagen assembly plant here in Accra. That is one example of using manufacturing robotics, because then you have cars that are going down an assembly line, and then you have perhaps one robot that's meant to weld the car chassis together, another part that's meant to rivet some parts together, another robot that's meant to spray the body of the car, another robot that's meant to screw in the tires onto the calipers, the brake calipers. Essentially, we need to be able to develop systems like that on our own, and we need to be able to do that on a large scale. That way, we can produce more things by ourselves and essentially boost the economy. I don't want to go into that part, but that is what we would want to focus on in the aspect of robotics. And the second is the ability to recognize the emergence of Industry 4.0 and the Internet of Things. So, if you're not familiar with the term Industry 4.0, it's basically looking at the fourth industrial revolution, where we are looking at the rapid advancement of technological applications or technological, in this case, developments, right? And in this case, one thing that's very interesting to look at is how, since the early 2000s, between the early 2000s and 2023, a lot of things have rapidly been scaled up in terms of technology. When you look at self-driving cars that was mentioned earlier, you want to look at laptops, computers. Before, in the 1980s and the 1990s, computers weren't such an easy thing to come by. They weren't such an easy thing to use. But in the last 20 years or so, computers have become so common, right? They are so easy to use. They are so highly advanced. We can do so many different things with computers. So, if you are able to recognize that at this point in time in the world, things are rapidly moving along, you should be able to adapt and move along with the world. Yeah. Then we want to look at demonstrating critical thinking for problem solving. So one thing that we lack in Africa as well is the ability to solve problems and to think critically to solve those problems. Sometimes we face certain problems and then we don't want to approach it in a systematic or methodological order, right? And because of that, we are left with outsourcing some of these problems to be solved by people who are not African, right? Essentially, you need to be able to develop a critical thinking mindset. That way, you can start solving problems on your own. You can start solving problems before they even show up. That's another thing we want to look at. Then, managing automation systems and developing the necessary skills to to compete in industry. So managing automation systems is something that I alluded to just now with cars going down an assembly line. If you are looking into a space where you are going to be doing some large scale manufacturing, where you're going to be using a whole bunch of robots to be doing so many things, or perhaps to manage those systems, you need to be able to make decisions that would prevent any sort of accidents. You need to be able to do predictive maintenance, all of those things. The ability to develop those skills is something that would contribute to realizing that African dream. Okay, so now I want to look at robotics at DTI, or the Design and Technology Institute. So for those of you who may not know the Design and Technology Institute, it's a private TVET institution here in Accra. TVET stands for Technical Vocational Education and Training, and it's mainly focused on providing skills training to creative students. And ideally, this skills training is what you are going to take directly and venture into industry. So DTI's whole vision or whole goal is to be able to provide that kind of skills training within these manufacturing industries or sectors. One of those really important areas is robotics. So looking at robotics at DTI and how we approach robotics and the African dream as a whole, there are some things that we want to be able to look at the robotics program. First is understanding basic programming and electronic concepts. As anybody who is venturing into the area of robotics or manufacturing, it's really prudent that you understand basic programming and electronic concepts. You should be able to program in at least one programming language, if anything at all. That should be able to help you think logically to solve problems. Same thing with electronics, to be able to develop systems that would solve some of those problems as well. Second thing is using design thinking methodologies. So at DTI, we would like to approach problems using design thinking. How do I use innovative ways to solve problems? How do I create a persona out of a problem? Let's say a 30-year-old a 30-year-old worker who is not able to transport himself from his house to his workplace effectively every day of the week. What is one way I can come up with solving that problem for that 30-year-old? That is going through the entire design thinking process. So you use that mindset you basically combine that mindset with the skills that you are learning to be able to solve some of these problems. Then we look at appreciating the goal of completing a task. So everything that we do at DTI is practical. So if I'm building a robot, I want to be able to complete a task by the end of my building of the robot. And I want to be able to appreciate that if I have built a robot to move one object from here to there, then I have completed the goal, or I've completed the task. That's basically all we are trying to do in a practical sense. Then combining various modules. So in this case, no module, let's say in robotics or programming or electronics, should be stand alone should be standing on its own. You should be able to combine them, essentially same thing you do with design thinking. Bring these concepts together and, if possible, collaborate with others to be able to solve problems. Ideally, the whole goal is to solve problems. So if you're not able to collaborate and combine these various modules and principles and fields, then you are not really going to be moving as fast as you would. And then there's just building robots for fun. So we can build robots to do some really interesting and cool things for us. And the fact that we are having fun while doing that is very important to the learning process. Okay. And then, yeah, so essentially going a little bit deeper into robotics at DTI, these are some of the pointers or some of the areas that we would like to touch on when we are exploring robotics at DTI. I'm not going to go through each and every one of them, but the bolden one at the bottom here says robotic applications in manufacturing. So, in a sense, at the end of the day, your entire goal is to be able to improve or scale up these manufacturing systems. And you are doing that by building robots, by programming robots, by fixing robots. So, at the end of the day, if you know how to build a robot, the next question is, would you know how to build a robot that can help you manufacture a product? That's essentially what we'd like to look at in the context of robotics. Then we'd like to look at the computer aided design and computer aided manufacturing program at Ashesi, sorry, at DTI. And over here, it's essentially combining some of these areas that I just spoke about and basically fine tuning them specifically in the context of manufacturing. So, in the previous slide, it talked about robotic applications in manufacturing. So, in this case, when you're looking at manufacturing as a whole, then you would like to think about all the different ways we could manufacture products. So, if it's by welding or by flanging or by painting or by riveting, what are some of these manufacturing processes and how do they work and how can we use robots to make them better? So these are some of the areas that you'd be looking at in terms of computer aided design and computer aided manufacturing. So prototyping, 3D design, CNC machining, additive manufacturing, manual drafting, and then basically the translation or eventually the translation into robotic applications. So by the time you start looking at robot applications in manufacturing, you should be able to extrapolate that that thought into what it means to be able to manufacture a product from start to finish. I hope I'm making sense. Great. So one thing that we like to focus on a lot is at the top, prototyping. So if I'm developing a product and I want to be able to test that product, I need to be able to prototype that product. There are various means of prototyping some of these products that we develop. And one very important way of doing that is by using additive manufacturing. What a lot of you are familiar with as, or a lot of you know as 3D printing. So 3D printing, the technical general term for it is additive manufacturing. So that looks at all the different types of 3D printing. So we want to be able to create models of the products that we've developed and see what they look like in the real world and how we can improve upon them or how we can make adjustments where necessary. Yeah. And looking at robotics and manufacturing, these are some of the areas of specialization that you would want to venture in as a professional or even as a hobbyist. These are some software and some platforms and frameworks that you can use to be able to develop these systems and basically utilize them to their full potential. In most cases, I know a lot of you are familiar with Arduino, and in most cases, Arduino is used as an introduction to electronics and robotics, but in most cases, you can actually scale up the use of Arduino to even much bigger applications, like in IoT, for example. Say you have a room full of people where all the lights are on and say the AC is on, like downstairs, and everybody exits the room, but the lights and ACs are still on. How exactly are we able to conserve energy by immediately switching the lights and the ACs off, right? Let's say I am able to do that using my smartphone. That is an example of building an IoT system to be able to do that. Or like with self-driving cars, like with Tesla, for example, where you are able to control different aspects of your car just by using a smartphone. Or you are able to retrieve real-time data from your house or your car or your room, and you retrieve it straight to your smartphone or your computer or any other device like that. essentially the ability to be able to communicate between each of these devices and communicate with some cloud network or some internet platform is what we like to um, term as the Internet of Things. And the Arduino interface or the Arduino programming language is one um, one really useful method of doing that. Oh, sorry, is one really useful method of doing that. Aside all of these um, other applications and software as well. So yeah, that pretty much brings me to the end of my presentation. So if you have any questions, I am open to answering them. Great. Okay, so in the job market of robotics, I'll just quickly go back to um, this slide, right? So this these five areas essentially um, give you a fair idea of what the job market looks like for anyone looking to go into robotics. As I've said, in the real world, if you're going to join a team of engineers or technicians that are going to be building a robot or designing a robot, there is a very, very high likelihood that you are not going to be doing everything by yourself. You are most likely going to be working on one specific task to contribute to the larger group or the larger team. And in this case, these are some of the areas that you'd be looking at. In my case, for example, I specialize in machine design. So if I'm looking at machine design, then I would most likely look at jobs that have anything to do with mobility or end effectors. So I like to program myself, but I don't find that as a strong suit. So if I'm joining a team that is going to be building robots, then I would like to join a team that's going to be dealing with hardware components. So that's mobility and effectors. Let's say we want to be able to move a robot across a forest area, for example, and we know that that terrain is rough and it's rugged, and so we need the robot to be robust. So as a designer, I'm going to have to think about what kind of materials I'm going to be using to build the body of the robot to be able to maneuver it across that terrain. I'm going to have to think about the lifespan of these materials. If, say, after 1,000 operations, is the material going to start wearing off? If not, is there something else I can use to make it last longer? Right. So essentially, each of these specific areas should give you a broader insight into what the job market looks like for robotics. I don't know if I've answered your question. You look unconvinced. Mhm. Volkswagen. So, one company that I have worked with in the past is Ozone Technologies. I don't know if any of you are familiar with them. So, Ozone Technologies is responsible for creating bionic human arms. So, in this case, where we look at amputees and people who have physical disabilities, we want to be able to create prosthetic arms or prosthetic limbs for them. You have just let's say for uh, a prosthetic leg, for example, all you'd have to do is probably take measurements and take measurements of sizes, lengths, distances, whatever, and then build up your prosthetic leg and attach it to the amputee, and they should be able to walk. Now, in this case, we want to be able to build a prosthetic leg where, in some cases, you want to be able to interact with your environment. So, let's say I am an amputee who has a prosthetic right arm, and I want to be able to pick up a bottle of water. Right. That uses aspects of robotics to be able to achieve something like that. So you are not necessarily building a robot to perform that task, but you are still using the aspects of robotics, the principles of robotics to achieve that task. So that delves into using building programs and in this case obviously end effectors, looking at mobility. If my prosthetic arm is meant to pick up a bottle of water, is it able to pick up a bottle of water that weighs this much versus picking up a bottle of water that weighs, let's say, so this is about 500 ml, right? So is my prosthetic arm able to pick up a bottle that's 500 ml versus a bottle that's 1 liter, right? Obviously, one would be larger or heavier than the other. So in this case, how do you design for both use cases, or how do you design for just one use case? So that is one way you can look at applications of robotics in the job market in Ghana. Any other questions? Okay, that's a good question. So he says that are robots only physical machines, or you can have robots that are virtual as well. So by definition, robots complete tasks for human beings that we usually would not complete on our own. So you could sort of extend that and say that robots exist within the virtual world as well. But then when you start to look at it in that light, then you'd have to start looking at things like artificial intelligence systems. So that also goes to programming as well. Because if you are developing an artificial intelligence system, then you want to be able to complete tasks that you usually wouldn't do on your own. So let's say you pick some data sets, let's say like in a bank, right? You have the data of, let's say, 500 people who have come to set up accounts at the bank and have made deposits. Let's say you want to be able to sort out that data as quickly as possible. And perhaps you wouldn't want to do that on your own. Perhaps you have that data in Excel and you wouldn't want to do that on your own because it would probably be too cumbersome to do. You would employ the use of a machine learning algorithm or an artificial intelligence program to be able to perform that task. Essentially, you are sort of using a robot, but you wouldn't coin it robotics as robotics. Then again, AI exists within robotic applications. So, yeah, one way or the other, yeah, it still works.
Okay, please, can you clarify the difference between a robot and a bot?
Come again.
Robot and bot.
Okay, so a, a robot, okay, so a bot is a term, is a technological term that was coined out of the term robot, right? So, with most robots, as we have discussed already, you want to be able to complete tasks that you usually wouldn't do, or you want to be able to retrieve information or communicate with the robot or that machine. Now, when bots were created, the whole idea of bots was to be able to interact with the software, in this case, it's software, in real time. So you interact with the software, you feed it information, and then it gives you a response. So it's very basic input-output stuff, right? So one very simple example of a bot is, I don't know if anyone uses channels on Telegram, right? Yeah, a lot of bots appear on Telegram where you are able to feed it information and then it automatically generates output for you. So these are based off of pre-programmed concepts that you are already, in this case, anticipating. So you are not necessarily giving it anything new. So all you are doing is giving it an input and then it's giving you an output based on that input it's processing. So it's very straightforward. So if it's A, give me B. If it's B, give me C, right? And in some cases, if it's C, I'm not going to return anything at all, right? That's essentially how robots work. That's how essentially how bots work. So they sort of come out of the whole robot idea. Any other question?
Please, last question. Please, is there, if any machine possesses one or more of these features termed as robots, or the features over there, the human robot interface mobility. So if a machine possesses only one, is it termed as a robot?
Absolutely. So, in most cases, let's say you want to be able to, um, let's say you want to be able to move this bottle from here to there, right? And every single time you do that, let's say you do that on a conveyor belt. So Belacqua is producing bottles of water, let's say 100 bottles of water every 20 seconds or every minute, right? And it's moving along a conveyor belt. Essentially, you would have one robot that is only meant to fill the bottle with water, right? That's the only task it's meant to do. So it's basically one dimensional, right? And it's most likely going to use only one of these areas of robotics. So, in a sense, it's still a robot. I've answered your question.
All right. Thank you very much. I'd like to ask if there are communities or hubs in Ghana that are basically of robotics.
Yes. So, the first community or hub I can think of is DTI. The second I can think of is the IoT Network Hub. And another I can think of is the Ghana Tech Lab. Another I can also think of is Innovate Labs as well. There's Kumasi Hive, there's Triple Dimension. Most of these places are either innovation hubs like IoT Network Hub or maker spaces that deal with programming and robotics and developing electronic systems that basically do these things for us. So a lot of these organizations are springing up really fast in our part of the world, and yeah, I'm excited for the prospects that it brings. Yeah.
Okay. I mean like free spaces where you walk in there, or like they have meeting days, you walk in there and then like they discuss and then really do this thing, not like an institution mainly.
Well, I wouldn't know of a space like that. But what I do know is that most of these organizations that I have mentioned are pretty open source and open to most people in the general public. So it's really just a matter of walking in and having a conversation about what's going on. Um, to really hit on what you are trying to describe, you'd be thinking about online communities. So one example of that online community is the Best Makers Forum. So it's basically a community of engineers, technicians, scientists who share information every day. So let's say I have an issue like we discussed downstairs with software development, like you'd go on Stack Overflow, on Slack to discuss with people within these communities. If you have an issue, you just send it to these guys, and someone who has experience in that area should be able to give their insight on that. Yeah. So these online communities should exist. Yeah.
So please to add up to that, I think IoT Network Hub is doing a really good job. So mostly every last Saturday of the month we have meetups which are free for you to attend, and we do trainings as well. So it's open to everyone. You can feel free.
Exactly.
Yeah, it's free. Sure. We start at 12 and ends at 4. So the flyer will be coming out soon. Probably this month there will be a meetup as well. Thank you.
Any other questions?
Yeah, thank you so much for your presentation. Have you tried applying AI to um, robotics? Because I'm in AI, and when you take most of the things in robotics, it seems AI can do. When you take something like sensors, there is something like computer vision under AI, which it can actually do. When you take something to like programming, AI too can do it in the sense that a branch under AI, which is reinforcement learning, and OpenAI also leverages on reinforcement learning to actually learn around its environment. And when you take the Tesla car ride like this, it's not actually a car as you see it or an automobile, but Tesla is a robot because it senses its environment using computer vision. So I am very interested in learning robotics, but with my AI skills, I think I would rather apply it to that than IoT, which I don't have knowledge in. So have you also tried applying AI into robotics? Thank you.
Absolutely. So I was going to give that same example where one very large scale application of AI in robotics is computer vision. So you take a machine learning algorithm and then you train it to be able to tell the difference between certain objects. So I use a camera and then I point the camera at the bottle and then I tell the machine learning algorithm that this is a bottle, and then I point it at another object and I tell it that this is not a bottle. So once I'm able to train it with that data, then the next time I point at another bottle and it tells me, yes, this is a bottle. So in my experience, using AI to develop robots, one experience I had was building drones. So I worked on a project where we were trying to aerodynamic capabilities of a particular drone, right? And in most cases, this drone is a drone that's going to be flying at high speeds, right, at low altitudes. In that case, you think about the drone interacting with things like buildings, right? So if it's going to be interacting with buildings, it needs to be able to tell the difference between free space and the building. So let's say you have the sky looking like this, right? And then you have a building that's painted almost the same color. How is the robot, or in this case, how is the drone able to tell the difference between sky and building? So we were looking at using computer vision applications to be able to determine stuff like that. Another area we were looking at was in robot rovers. So in a robot that's able to maneuver its way and dodge obstacles, it needs to be able to tell that this is an obstacle and this is not an obstacle, and it is a path I can move through, right? But in my case, like I said, you are not going to be specializing everywhere. You are most likely going to be working with someone else on that project. I didn't work on the AI side of it because that's not my specialty. But yeah, that's one way um, we applied it.
Thank you so much. And then final question. We are treating the tech through the African dream.
Right.
And I'm very passionate about we Africans creating things from scratch. And I did my research and I found three levels of creations. We have a creation where you use American foreign systems to create foreign stuffs. We have a stage, another level where we use foreign systems to create stuffs that fit the African systems. And then we have another level too, which many people I don't think like they are doing. That's to create something from scratch to be able to leverage on substance for the African system. So is there a way that we can create something from scratch? Something like maybe when you want to create a device, you actually have to program it. So you want to create a programming language to be able to create a device. Everything from the African like environment, but you are not incorporating any foreign material. You are just using resources around you to be able to create something that will fit the system. Is there a way? Like, yeah.
Yeah, there's definitely a way, but I do think in my personal opinion, I do think an approach like that would be a little counterintuitive and counterproductive because the systems that have been there for years are there for a reason, and they are not there so that we can ignore them, but they are there so we can leverage on them. And I do think it is possible to create things from scratch, but when you do that, you would be using up way too many resources and way too much of your time. One example I would give is, let's say you are in an African setting where you want to build the first ever African made car from scratch, right? Now, the problem here is you have vast resources to be able to achieve that. But in industry, you need to be able to follow certain standards. One very important standard is, for example, the American Society of Mechanical Engineers. They have published a whole bunch of standards that you're meant to follow. For example, the safety factor of using certain materials in manufacturing. Build a car. and that car is going to crash, for example, I want to be able to make sure that in the unlikely event that my car crashes, it should be able to protect the user or the driver to some extent, right? Now, these tests have been done over and over and over again to be able to develop these standards. That's where you know that once you are building a car, you are not allowed to use, let's say, an aluminum sheet that is less than 10 mm in thickness, right? Going below that standard or going below that rule essentially puts people in danger, right? So trying to figure out how to do some things from scratch is a little counterproductive, but it doesn't mean you can't be innovative at all. If you want to do things from scratch, then essentially you want to be inventive. But if you want to be innovative, then you take things that already exist and then improve on them. Another very um, critical example is I hope you guys know that when car manufacturers are making cars, right, they are not allowed to take out the side view mirrors. I don't know if you guys know that, right? Essentially, if you take out the side view mirrors from a car, you are going to take away over 30% of the air resistance that a car is going to be experiencing while it is in motion, right? So the thing is, most cars, when they do computational fluid dynamics to test those models, they realize that a lot of the air resistance and a lot of the time where the car is using most of its fuel is because of the side mirrors, because it's just there blocking the flow of air. So the engine has to do more work to push the car. So Tesla came up with an idea where the new Tesla Roadster was going to have no side mirrors. But after it was presented to the general public, it wasn't allowed to be mass produced because it was going against standards, right? You can't manufacture a car without side mirrors. It's dangerous. So even though you are being inventive by creating a car that significantly reduces air drag, yeah, you are putting people's lives at danger. So yeah, you have
Thank
to
you so
follow the rules
much.
sometimes.
I now understand. Yeah.
Any more questions?
We have two programming languages that
Building programming languages from scratch is a very very difficult task. Or frameworks. Okay. So yeah, frameworks, programming languages. I mean, building these things are incredibly difficult, and doing them on your own is even way more difficult, right? I mean, I remember when I was a backend developer, we're using JavaScript and Node.js to build applications on the backend, and at the time, Flutter had been released, right? And Flutter presented a whole new way of doing things. At the same time, a couple of years later, Google released Go. Right? Go was a programming language that Google had released, and it seemed to be able to perform tasks at a much faster rate than your average programming languages like Java and Python. But this is as a result of hundreds and hundreds of software engineers and computer engineers who have come together and are leveraging on each other's resources and experiences to be able to build infrastructure like that. But in our part of the world, that is, yeah, essentially almost impossible. So, like I said, to be able to realize the African dream, you need to be able to work towards building your skill level to that point, right? That's where we start leveraging on each other. Like someone mentioned with these communities where you have a problem and you need it solved or you need help solving that problem, you leverage on other people's expertise. So that should sort of put us in the right direction towards fulfilling the African dream. Any?
Oh, okay, so I also like to say something about what he said from building something from scratch. So I would say when you want to do something, it's in stages and process. So there is no like nobody in this world that builds something from scratch. Especially if you want to build a car, there's nothing like you are going to manufacture your own metal from the scratch. So let's say using the raw material, it is one company who will do the metal for you, then another company to go and buy it, and so let's say do the modeling in their company, and another company too will go also and buy the models and also come and assemble it. So there's nothing like building something from scratch. So especially let's put into this scenario. So right now, if I want to build helicopter, so and sun, combine them to to build my own resistors, my own diodes, my own LEDs, and print my own board. Do you get it? So this is going to consume my time, my resources, and it will get to a point I will lose trust in my ideas. And when the ideas comes, it comes as a signals. If you don't quickly, let's say, work on that, it can vanish. So what I would say is that when you want to do something, never think of building from scratch. And also for security's sake and also for functionality, speed, accuracy. So they all count to that. So that's what I also say.
Yeah. Yeah. So one simple example is for example Rolls Royce. You guys are familiar with the car brand Rolls Royce. Um, I'm sure a lot of you don't know that Rolls Royce also manufactures turbo engines. So you know that all these airlines that we use to travel, United Airlines, Delta, KLM, yeah, Ethiopian Airlines, most of these guys use airplanes that are built by either Boeing or Airbnb. Boeing and Airbnb further outsource the building of their turbo engines to Rolls Royce, right? Because they are the experts in developing things like that, right? Rolls Royce is also responsible for some of the locomotive engines that are used in the Euro trains in Europe, right? So essentially, if you are developing any product of any sort and you're really going to do it from scratch, no. So, if anybody has any more questions, you can ask them. I want to show you a short video on some of the things that we've been working on at DTI and how we are trying to approach robotics and manufacturing. Any more questions? So that's additive manufacturing. So we 3D printed uh, a mask. So that's CNC machining. So if I want to be able to develop the different parts for my machine, I would machine them from raw materials. So this is an example of combining a lot of programming concepts in robotics where we are processing signals to be able to communicate between devices. So communicating between the smartphone and the robot's arm. So if you're developing any system, you need to be able to design it. So some of the design software that I referenced earlier would come into use or come into play in this case. And then at the end of the video, we would see essentially a culmination of all of these concepts that we're studying or we're developing at DTI for a very large scale project of sorts. So we're combining electronics and programming to be able to develop a spectrum analyzer. I think you would see what it does at the end. Yeah, so that's basically it. So we combined so many different aspects of manufacturing and robotics to be able to build something like that. So it takes in sound and then translates that sound into moving lights. So that's one application. You could think of it as something that could be for entertainment purposes, for example. Yeah. So like with the DJ sets. Yeah. All right. If there are no more questions, then I think we've had a full discussion.
Wow. Thank you.